Hi everybody. How y'all doing today? Having a good time? Back at the Sustainable Enterprise Conference. This is amazing. I'm Ted Tiffany. I'm with the Building Decarbonization Coalition. I'm going to announce Diane as soon as I transition the slides over to her and let her introduce herself and what she's been up to. This title was, moving forward. Building Decarbonization and Why It Matters. Does anybody not hear, everybody who knows what building decarbonization is, raise your hand. Keep them raised. You heard the term building decarbonization before the pandemic era. Keep your hands raised. Building decarbonization before the fire events in 2017. All right. 2015, keep your hand raised. 2010. Okay. So this is the era of progress for the building decarbonization, and we're past this awareness phase where most of you are aware of what building decarbonization is. So we are moving into the next phase of deployment. We're going to talk about that today. The BDC, the Building Decarbonization Coalition, was formed around the 2018 format, but we are an advocate organization, nonprofit. Our membership is a lot of manufacturers, utilities, community organizations, environmental products, and stakeholders across the region to work on building decarbonization. From anything from house transition to neighborhood scale. We're going to talk about how wide this challenge is for us today, and we're going to get into why kitchens are key to building decarbonization. Our priorities are really to align policy right now, accelerate adoption, and pilot building decarbonization on the neighborhood scale. And we're past this first stage, as I said. Part of the awareness campaign in the first 5 years, 8 years, 10 years, if you've been working on this as long as I have, is really raising awareness about how we get off of the gas system and onto clean renewable power, and why the connected organizations like Sonoma Clean Power are going to accelerate the clean renewable power that we will transition to over time. So there are a lot of things we don't touch. Like I let Jeff Cyphers work on the clean power side of the equation. We're working on buildings, the technologies, and the knowledge and design awareness to get off of fossil fuels. Because buildings are a big part of the problem. You guys have likely seen this slide before, but commercial residential buildings, 30% of the building's emissions. And we are starting working on industrial scale decarbonization in some of our realms. We can talk about that as specialties of farms, breweries, high power glass making facilities. All of those are in some different stage of decarbonization, but those are the industrial scales we talk about. But we need to get buildings off of fossil fuels to meet our renewable portfolio standard requirements, and there are a lot of them. The majority of U.S. states have some kind of energy efficiency, greenhouse gas reduction, or renewable power goal towards our net 2030, 2040 goals. And the success of any of those clean power requirements are to get buildings off of fossil fuels and onto the electric system. So there are a ton of buildings. How many of you guys are in big cities like San Francisco? Did you come up from the Bay? No? Everybody here is fairly local, right? Santa Rosa, we're starting to see some of those high rises pop up, right? Buildings are going to be our major challenge, both new construction, but also existing buildings. And existing buildings retrofits is where I have a sweet spot for. But getting these buildings off of the scale of gas that we have currently is a big challenge and takes a lot of coordination. And we can't do all of these things in a disjointed fashion. Right now we have mandates discussed, we have appliances that are evolving, we have manufacturers on a different time scale, we've got utility planning systems on a very different scale, and policy and application on another time scale. But we need to as a convening organization that BDC is, to bring these groups together to make sure the pieces fit and they align on the same timescales. So we are a stakeholder engagement expert. We like to bring people together and do some deep listening about what are these deep challenges, what are the things that this organization needs, this manufacturer needs, and have those groups talk. One of the things we just announced 2 weeks ago now, the California Heat Pump Partnership Blueprint. And you can look that up, the California Heat Pump Partnership. Their entire goal was to get 6 million heat pumps deployed by 2030 in California. That interest is growing nationally, but getting those stakeholders together, like the California Energy Commission, California Public Utilities Commissions, the manufacturers of equipment, so Trane, Daikin, Mitsubishi, bringing all those groups to the table to see what are the barriers, what are the new policy applications, or how do we streamline permitting, how do we bring things to market in an accelerated timeline. And home decarbonization is hot. How many of you guys shopped for anything related to a heat pump, induction, or some path in electrification in your home? So a lot of you. How many did that before 2020? All right, so you can see there's progress and acceleration of this home by home decarbonization. And there's lots of incentives and everything like that. And we have a lot of our staff here from the Switches On campaign, which is all about, thank you. Nice to see you. It's nice to see my colleagues in person. But really that is about home by home education of what these appliances are, the process to install them, connecting to contractors, making sure you know which incentives are available for, and what's coming down the pipeline. It's a lot of information sharing, a lot of engagement, and we do that through community. Our ambassador programs are in the community, really talking to people throughout their electrification journey. And the house by house application is great, but it's not going to get us to the scale of decarbonization that we need. And we really need to scale neighborhood decarbonization. And that's transitioning neighborhoods to the electric system. We call that the electric network transition. It's like air source heat pumps, air source water heat pumps for domestic hot water, induction stoves, things like that, to put everything on the electric network. In larger cities like New York and Chicago, we have a huge steam problem. We have a huge hot water distribution system that are district systems that we need to transition into thermal energy networks and what we're calling geothermal networks. So if you've never seen one of these, Santa Rosa Junior College has an ambitious goal to transition their campus over to the geothermal network. So they've created geothermal wells there and are retrofitting buildings by building. They have 3 on the network now. They're about to connect their 4th and 5th this summer and transitioning that to geothermal network all electric. So we're trying to expand that in big cities where thermal networks make sense. So that allows us to scale equitably. It allows us to transition entire neighborhoods together so that we don't have just the affluent people that can afford to do house by house, but we're also using our mass transition strategies like utility planning or even community-owned networks that gives everybody a little bit of energy sovereignty. And so that transition planning on the neighborhood scale, while we're doing these really expensive pipeline replacement projects, we can put thermal networks on the ground to connect everybody with water in the pipes. So I'll stop there, but you guys can always ask me more questions in the Q&A. I really want to talk about why cooking is so key to the decarbonization movement. On these neighborhood scale projects, we have to get agreement for everybody to connect or do neighborhood scale electrification together. And the most controversial thing is this is how I cook. I've been told gas is better. Cooking on gas is faster, better. Every celebrity chef in history has told me cooking on gas is the better way to do things. And not a lot of people know that the American Gas Association helped sponsor Julia Child's Kitchen. And she was the original cooking chef that taught you cooking on gas. And that's why that message is so powerful, because every one of our celebrity chefs that we connect to with our own communities has taught you in some way how to cook for your families. Every one of us cooks differently in our kitchens for our family, and food brings people around to everybody's table. And that's why we've been training chefs on electric cooking about the transition to the electric kitchen. And this is where I want to introduce Diane Wheeler, because she has gone through our Chef Learnstar campaign and is now educating folks on clean induction cooking. So, hand it off to you.
Questions when we get there. So yes, I'm Diane Wheeler. I come from a sustainable commercial real estate development background for 20 years. And my passion has been cooking since I was a kid, and I'm lucky enough to be part of the BDC's Chef Learnstar program, and I get to go out and educate homeowners, architects, builders, and commercial kitchen folk about induction. And so what we want to say about it is that a lot of people don't know what it is. So the first question is, what is induction? And some of you may know a lot of this, so excuse us for speaking to the crowd, but so induction is electrified cooking through a magnetic system. It creates heat in the pot directly with the magnet, and so from an efficiency standpoint, you're not having the flame go up around your pot into the room. You're basically creating a 95% efficient delivery of heat into your cooking situation. From there, you also get there are a lot of studies I'm sure you've heard, and I'm sorry, I'm not going to go with the slides because they don't quite match but if there's anything I miss, you know. There have been a lot of reports lately about the toxic air quality that comes from gas, and so in the induction situation, you're not combusting fuel, you're not creating carbon dioxide, nitrous dioxide, methane, formaldehyde, or anything. There's no gas happening, and so you have an air quality improvement that's just hard to argue with. From an induction, from a chef standpoint, a lot of people don't quite know how to use it or what it is, and so we like to show it. So at 4 o'clock today at the reception, I'll be there making some mushrooms, and you can come and watch me cook. You can touch it, you can see it at action, you can ask me questions. But chefs who use it really love it. It's a high efficiency, clean, safe, there's no flames, cool, it doesn't heat up your kitchen, easy to clean, but more than that, the low and high of the temperature ranges are better than gas, so you're going to go lower lows and higher highs. A lot of mythology is that you can't do with induction what you can with gas. You can do everything with induction, all the way into the commercial kitchen, from charring to searing to melting chocolate, to making pizza, to grilling, to griddles, to combi steam ovens. It's an amazing new field of electrical appliances, and every major appliance maker is getting into it. So, you know, Viking and Wolf and AGA and LG and G and all the rest of them, everybody's in the game. From a home perspective, we like to talk about the cost point to get into induction. So when you're in your kitchen, already you're about 80%, 90% electric. If you think about your air fryers, your Instapots, your toaster ovens, most of your kitchen is electric. The last frontier is your gas stove. So if you change to induction and also your HVAC and your heat pump, like as you move toward decarbonization and full electrification, you actually can shut the gas off in your house and run your whole house on electrical and begin to shut your house and your neighborhood as homes go. As Ted was saying, the neighborhood solution is one where we're letting go a whole part of the infrastructure that delivers gas, leaks toxins, etc. And the price points can be anywhere you want them to be. So for the low income or the renter whose landlord doesn't want to put in electric, you can get into an electric kitchen for, this is a hob. It's a cooktop. It's just a one burner, $50. And they go upwards for the hobs, which are countertop. You don't need to get rid of anything. I actually, in my rental home, capped my stove, created more counter space, and I have portable hobs there because my landlord didn't want to change it over. You can get these for $50 to $400. You can do just the countertop install for $400 to $10,000. You can do, combi stove and ovens for $400 to $20,000, just like gas. There's the low end, there's the high end. If you want the fanciest home kitchen you could ever have, you can do it, and if you want to get in at a budget level, you can do it as well. Something people often say to us is that my pans won't work, and that's not entirely true. Most pans, in fact, do work, and if you have something at home, cast iron, Le Creuset, your all-clads, whatever, just stick a magnet on it. And if it sticks, that pan is going to work on induction. For people who have pans that don't work, you can either buy pans that do, from $200 for a set of pans at Target or whatever is politically correct to get sets of pans now, or all the way up to buy your fancy pans just like chefs do for $800 or $1,000 a pan. Really, any price point works. And if you don't want to do that, you can get a diffuser plate at, again, Target or wherever's correct to get a diffuser plate. And then your pans will work. And all of that to say is the technology of it, from a chef's perspective, it's fantastic cooking. It's ultimate control. It's efficient. You're pulling less power off the grid, so your bills are less, not because, and this is a different conversation we won't have here or we can have after, the price of gas and electric is an ongoing fluid situation. What we can talk about with induction is that it's an efficient appliance. It's pulling a lot less energy from your grid. And so the cost points are going to play out over time. From a commercial, and this is an enterprise conference, excuse me, commercial kitchens, as we talk to people about going in this direction, we're beginning to have data around the economic argument for running your commercial kitchen on all electric. And so that's exciting, I say, because a lot of this, the data is just coming in, and it's coming in the positive. So that's great. I feel like we have 5 minutes to get this all out, so I'm hurrying. I think now we've given you guys a lot to think about. Timing-wise, should we go to questions and answers to give ourselves?
We've got 10 minutes.
Okay, that sounds good.
I'd like to take like 2 at the end if possible, but go ahead.
Sure.
They're all 240?
No, there's a movement in the electrification area of appliances. A lot of them are coming out at 110. So, and that's a great question, because when you're doing a home and you have to convert your panel, and Ted can speak to this.
No. Keep talking.
Okay, that's great. When you're building a home new, it's easier to create a panel that's going to work. But there are a lot of things happening. One, a lot of the equipment is moving toward 110, which is something that we need. 2, there's something called electrical calculator, where you're designing the way your home uses energy around your 110 or your existing panel. There's also some induction equipment on the market that is now coming out with batteries within it, so you can plug them into 110. And some of them, what we work with a lot, called the Copper Charlie, has a battery in it. Is that it? Right there. Oh, that's one there. Can actually run for 3 to 5 days. So in a power outage, which up here we have these public safety power shutoffs, or whatever they're called, you can actually use the stove to charge your fridge and keep cooking. So there's a lot going on in that space, and that's a great question. Yeah.
What impact does it have for commercial applications for fire suppression? Is the fire risk profile changed?
Well, that's not my greatest area of expertise, but you have a lot. What you have in the kitchen when you're using a fully induction or a fully electric kitchen is, for one thing, you're a lot cooler in there. So your HVAC load is a lot lighter because you're not heating it up to cool it down. In terms of fire suppression, I don't know the code on that. Ted may have an answer.
So I like to do flambés. on my induction. I have to find a lighter to light it now. Same with grease fires. You don't have an active flame to really induce fire on what you're cooking. Yes, you can burn something in a pot if you leave it on anytime, but you don't have that active combustion next to
I was just wondering if that's cost savings for someone installing a commercial kitchen.
We're trying to get the insurance agencies to actually recognize that safety factor.
Yeah.
So yeah, you're absolutely right.
But I do think for like small commercial kitchens like Lunchat and Paloma, I think that it made it so they didn't have to do the big exhaust systems because there's
Yeah.
no gas. Do you know what I mean?
Yeah, smaller.
Yeah, with induction, you're no longer having to vent for toxic chemicals, but you are gonna wanna vent for steam, grease, oops, I burned the bacon and it's smoking in the house. But the ventilation in the commercial realm is a very new, highly efficient kind of venting system that does a lot of its own monitoring and ultimately saves a lot of money in the kind of vents that you need for a purely electric kitchen. Go ahead.
You want a good joke? I come from the engineering background. They have a smoke and heat sensor that you're required to do on big kitchens. And a couple of years ago, we actually had to tell them the technology doesn't work for induction because it doesn't generate the same smoke and heat as a gas stove. So they weren't triggering the fans. So there was an adjustment period of that technology to actually recognize the reduced airflows over these kitchens. And we toured a lot of these electric kitchens. There's a lot of them in San Francisco if you want to connect to one of those. But the chefs all say, like, I don't have the fume hood noise. I can talk at a normal voice to all of my chefs. One of the chefs gave me a really good anecdote. He's like, I stopped drinking the gallon jugs of water because I'm not sweating it. I don't have to do that replenishment. So it's a huge health and safety factor for them. And as we're talking about cooling rates in kitchens, other events like that, like it's a huge reduction in the ambient temperature.
Where's the joke?
The joke about the technology not recognizing the fume hood. Sorry, it was an engineering joke.
Yeah, and to further that, commercial kitchens, you're going into a kind of labor savings and employee comfort levels that are, again, not what this panel's about, but happy to talk about it tonight. And the future looks bright in that way, and chefs love, when they go there, they love it. It's hard to get them back, yeah.
So you mentioned that you work a lot with retrofitting, maybe older homes and remodeling and stuff like that. So what I'm wondering is, it seems like a lot of our homes that are older only, we used to have 100 amp panels when we had a combination of gas and electric, right? I just did an ADU that had a 200 amp main service and everything. The ADU small, it's only 800 square feet. We had to put a 200 amp panel in there to go 100% electric. We're constantly blowing breakers because there's just not enough electricity to run the small electric ADU that we're doing, because the house and the ADU both share that 200 amp panel. And so I have a 200 amp panel in the ADU, a 200 amp panel in the house. So I'm just wondering, are they making this stuff take less energy so that the infrastructure of the actual power source, without having that PG come out and put in a brand new cable and wire and bigger panel?
So Dan started to touch on this called the watt die approach. And the selection of appliances is really important. These 120 volt stoves actually reduces the impact on the 240 application there. Being smart about the appliance installation, I have a 1917 Craftsman home on a 100 amp panel, completely electrified. Because I was able to do that work of saying, okay, here's my limitation of my water heater. I made it into a 120 volt water heater. I didn't go for the 240 with the backup electric resistance heating. So yes, being smart, educating our contractors and electricians that we don't really need that application of breaker wear, a huge amount of breakers, a 200 amp panel on an ADU, and it's blowing breakers. Yeah. I want to go see it and figure out who designed it, because that's wrong. Let's talk about what's
the design. So education, I think, is where we need to go.
I have an ADU on my property with a separate 100 amp service, and it never draws more than 20 or 30 amps, even with all the electrified equipment. So something's going on there that let's dig into. Yeah.
And I'll attest to, I have an 1890s Victorian on 100 amp service, but we got one of those smart
Yeah.
span panels, and it's been fine.
So
And it has the car charger regulates, like it'll slow down if you're on the stove, that kind of thing.
So there are smart plug devices, smart panel devices that we're trying to get into the National Electric Code right now to clarify these technologies. And then that'll be hopefully adopted into code if we're not stopped by this legislation.
And these are good questions too, because it's happening in the home level, at contractor level, at architect, designer, builder, appliance makers, engineers, policy, and up. And that's the effort, in the sense that Ted was talking about it. This all has to be happening together, and it is. Yes.
I hired an engineer tenant improvements where they're cutting these huge hoods in old buildings for these new kitchens. Does this get away from the requirement to cut the hood? You mentioned he doesn't run the hood.
So let's talk about that, because there is an exhaust hood and a recirculation hood, and there are nuances between that. So let's talk about that.
As an architect, the key word seems to be resistance heating. Like if you can, and a lot of times it just takes so much effort to find in the fine print whether they used a backup resistance heater to make that heat pump always work and always produce enough electricity, but we don't need it. And like, if you could just find out that it does not include resistance heating, which is the stuff we were getting away from 10 years ago. Now we're doing something different, but they're afraid of people complaining that they don't get enough hot water, they don't get enough heat, so they put this backup system. That's why they end up being 240 volt. But if it's 110, it's the new technology that we want. So just look between the lines, basically.
The education is ongoing, and 3 years ago we didn't have a plug-in water heater, right? The manufacturers didn't have those ready to market. Now there's 5 different manufacturers that supply them.
Which totally changes
The
it.
awareness of contractors that are out there in the field and having to take some time to even know that technology exists is our job, not theirs. So we need to meet them where they're at and make sure they know about that product to be able to have that conversation when somebody's doing a simple water heater install. Right. If they're out of hot water, that is not the time to have an engineer discussion. It needs to happen way before that. So thank you, Mark.
Sure.
So happy to talk more and answer any more of your questions. Come find me. Like, I love chatting on these things.
Quick comment, one of the things that led to this session,
Nope, that's not mine.
okay, is that in Contra Costa County, we took advantage of a grant opportunity to give away induction burners to people in low-income communities. All right, so we got a grant and identified 7 organizations to work with in the community. And instead of going through all the education process and encouraging, just give them damn stoves. So we got a wholesale price on Duck's Top induction stove top single burner, and like $30 for a set of induction ready cookware. So gave it to the folks, and then we followed up with surveys. And I don't have the time to show you the charts and graphs, but it clearly changed their behavior. The adoption rate was very high. Regular use of the device, their satisfaction level was very high. We use word of mouth to spread it through the community, so leveraging just a little bit of money and seeding the community ripples out. So if you want more information about the Cook Smart program, see me afterwards.